Thanks for joining us today on HXGN TV. I'm your host, Kyle Phelan. Today we're going to be discussing the MEGAROB project. We have Joel Martin, Laser Tracker Product Manager from Hexagon Manufacturing Intelligence, and Jose Antonio Dieste, Engineering Manager at the Aitiip Technology Center. Guys, thanks for joining me.
Thank you, Kyle.
Thank you. Joel, I'm going to come to you first. What is MEGAROB?
MEGAROB was the idea of creating a functional platform for the factory of the future, looking at the manufacturing challenges that are ahead of us and how we're going to solve them as we move into the future. So it was really trying to build a flexible manufacturing cell for very large objects. The cell right now is 20 meters by 6 meters by 5 meters in size. The idea is to be able to mill big parts with the accuracies that we would traditionally see with a small milling machine, but over a very large volume. And to do it, we essentially used a common off-the-shelf robot hanging from an overhead gantry crane system, being driven by a laser tracker to correct its uncertainties.
Now, with something this size, what does it take to make this dream a reality?
Yeah, the core of this really came down to the laser tracker itself. Being able to use data from a tracker, drive a robot end effector in real time. We actually have a video that we can show, and I'll talk a little bit over it, where you see a milling end effector as it's going through a process. And the piece on top of the end effector is called a TMAC. It's a device that allows the tracker to measure its position in 6 degrees of freedom. On the screen now you can see the laser tracker actually measuring the TMAC and where it is in space. We're using that data to feed back into the robot control loop and have the drive of the robot really be from the end effector of the robot, so that everything behind the end effector, the robot, the crane, all of the substrate, nothing else matters. The only thing that is critical is the milling head and what the milling head is doing in the process.
Okay, and Jose, I'm going to bring you in here. What was the main objective to developing the MEGAROB?
Okay, so the main objective is due to the problem that we detected in our technological center. We are trading with many customers, and there is a common problem for manufacturing large parts. Okay, so there is still a lot of manually performed manufacturing processes. Our customers needed something automated, and with accuracy enough to fit their requirements. This is the main reason why we created MEGAROB. So we searched the best consortium in Europe in order to perform these objectives.
We have a picture as well, Kyle, of some of the companies that are involved in the project. It was a total of about 7 different companies through 4 countries that were involved in the European development project to bring MEGAROB to life.
And with all these companies that helped you out with the MEGAROB, what is the accuracy you achieve?
Okay, we have to distinguish 2 different accuracy concepts. Okay, one is static accuracy and dynamic one. Static is when we are moving the robot to a fixed position and we stop the robot, or we are going in very slow movements. So then we can achieve accuracies better than 50 microns. Okay, for example, when milling, we are in dynamic mode. We are moving quite faster. So in this case, with the experiments we have done and with the demos we have performed for our customers, we can reduce the accuracy below 0.3 millimeters.
Who can benefit from this?
I think a large potential customers can benefit for this technology, because it's the first time that a high accuracy position sensor like a laser tracker is not only used as a metrology device, because it's used for sensoring all the position of the machines. So we are tracking the tool and we are tracking directly all the manufacturing process. So any industry that wants to increase their accuracy in their machines could be benefit from MEGAROB system. But we are focusing in large parts, so industries like aerospace, rail shipbuilding, construction can be benefit from this new system.
We have a video as well, Kyle, if you want to see, on the system actually cutting. You asked on accuracy and what kind of accuracies we were able to achieve.
Right.
We can show the video quickly. It shows the system actually cutting a couple of demonstration shapes that we did in the project. And you can see the difference between the dynamic accuracy and the static accuracy, as Jose had commented on. When the mill cuts through, you'll see it come back and trace that same process. Robots are traditionally very repeatable, but we're not using robot repeatability here. We're truly using the accuracy driven from the metrology system into the robot to recut these paths and show the accuracy that's achievable in the project.
So what could be done in the future?
Okay, we have a lot of concepts and ideas for the future. The first one is to implement these kind of solutions for more robots, because we have started with Comau 1, but you can see in the show that we are using also for Cubica robots. More robot brands are open for us in order to implement the system. Okay, also we have started with a rotating tool, so we can perform milling, polishing, grinding, everything with a rotating tool, and it was quite difficult to start because we were trading with cutting forces and so on. So now we want to extrapolate to new manufacturing processes. For example, laser cutting, water cutting, also welding. We can use also for automatic assembly of parts in aeronautics. We can use for riveting, screwing, more manufacturing process. And also, we started with a crane because it's a common infrastructure that can be found in all our customers in industrial workshop. There are plenty of cranes that we can implement this system in these cranes. Also, there are new possibilities for implement the robotics controller in mobile platforms in order to work from the floor also.
Again, we have a picture as well from a specific customer application. I think Jose can talk a little bit better about the application that we did as a part of the project and the prove out of the technology for the project as well.
Sure.
Yeah. This is one of the first demos we did. This is a composite beam for making bridges. It's from a Spanish company, a large company called Acciona. It's a composite beam made in carbon fiber and glass fiber. They use because it's very lightweight, so they can transport it by helicopter to parts of the wall or zones that are very difficult logistics. So they are using now even for corrosion in the seaside, for example. And that we did is normally they produce it by laminating manual process, but afterwards we have to cut it into shape in order to fit in position.
Right.
So in the past they did it manually, so they have a lot of problems with rejections, accuracy, and now we can do it with high precision, high tolerance, so we can make even more different shape cuts that they did in the past. And so we have made a lot of holes that are necessary to install screws and riveting for the assembly. Okay, so we can reach this high accuracy, 50 microns, and we can perform more than 200 holes in only 2 hours. So it's a large step for them.
That's definitely a lot. And regarding these cutting-edge technologies like the MEGAROB, what comes next?
Okay, so we are going to start in the coming months a new research project. So we call Kraken, and we want to hybrid additive manufacturing process with subtractive ones. Additive manufacturing processes are very trendy, but they have some problems, okay, with the materials, with the accuracy, and with surface finishing. These problems can be solved if you hybrid or support this process with subtractive ones that like the ones that we have shown in MEGAROB, for example, milling or grinding or polishing. So we want to make one of the largest 3D printers in the world, but with the performance improved.
Another exciting part of that project is it brings a very similar team together that did the original MEGAROB project, but it adds one more layer, and that is Vero, which is our own Hexagon software company, which is involved in the project as well, doing some of the CAM work that will come into the project. So it's an excellent additive and really shows the strength of Hexagon as a total network.
It's a quite large challenge because now there are no software for make a hybrid manufacturing, so they have to make a quite good development.
Okay, well, I'd like to thank our guests, Joel and Jose Antonio, for joining me here today. For more about MEGAROB, you can visit megarob.eu. And to tune into additional episodes of HXGN TV, log on to hxgntv.com. Thanks for watching.